Okay, we should get started. Today, we are doing, we're going to finish up 5.3, and we're going to get into 6.1. We will not get to 6.2. But you have Connect Math 5.1, 5.2 due today, as well as Project Lab Part 3 is due today. So if you have those, go ahead and turn them in here. Like I said, they can totally be black and white. And like I said, mentioned earlier also, there may be, it's very likely that you may have your kind of your imaginary classes that you make in front and behind. It's very likely that one of those could be a negative number. Your front one could be a negative number. That's totally possible. Meaning your class could be a negative number, like negative 1 half. All right. If you did not get to it today, you can turn it in late for full credit on Tuesday. However, today is the day to get all of your sob stories in, right? No excuses Tuesday. Today is your day for excuses. All right, because it's due today. Also Tuesday 5.3 is due, and then next Thursday 6.1 is due. Our exam is going to be on Thursday, March 12th for you guys. It's going to be covering chapters 3, 5, and 6. There are going to be 2 parts to it. The first part is going to be no calculator. However, I've decided I will allow a kind of a very, very, very basic calculator, one that does addition, subtraction, multiplication, and division. That's it. And then you'll take that part. You'll get like 10 to 25 minutes to do that. Turn that in, and then you get part 2. And when you get part 2, then you can use your calculator, your TI 83, 84 calculator. And you will need a TI 83 or 84 calculator to do part 2. It covers chapters 3, 5, and 6, but not 6.4. And you again are allowed 1/2 page, one-sided of handwritten notes, handwritten by you, right? Of an 8.5 by 11 sheet, half sheet, one-sided. So, all right. So this much, one-sided. Yeah.
You said previously if we just fold.
Yes. So if you've done half sheet on your exam 1, you can just use this part for exam 2. That's totally fine. Because I know the difference. I can tell the difference between exam 1 notes and exam 2 notes.
Does that roll over?
Yeah, and then exam 3 would be here, right? And then your final would be here.
Okay.
Yeah.
And then for the final,
You can use the whole thing. Yeah. Okay, quiz problem 1. So again, we did it. You have to use lists. So you put this in list 1, you put this in list 2, and then you did stat, calc, 1-bar stats of L1, L2. Right. So it would look something along the lines of. Let's do this. Stat, edit, and then you have this stuff in you put all the stuff from all the x's in list 1, all of their probabilities in list 2, and then you guys did stat, calc, right arrow over to calc. 1-bar stats is the one you want, so you either hit 1 or hit enter. And then you want L1, L2, so second L1, so you see the L1 here, comma, and you want L2, so you have to hit second L2, and then hit enter. If you have a fancy calculator, it may prompt you to put L1 in the list and put L2 in the frequency, and then hit calculate, and it'll do the same thing. And you'll notice it gives you X bar, which you don't care about the mean. It gives you the sum of the x's, the sum of the x's squared. There's no SX, right? There's no sample standard deviation because our n is 1. It realizes that can't possibly be a sample. And then it gives you the population standard deviation, which is what you want. So this is going to be 0.867 if you round. And it is a sigma because it's a population. It's anytime you're talking about a frequency distribution, so a probability distribution, those are for the whole population. Those are always going to be sigmas. Yeah?
The calculator didn't give me S, so how did it know that it was population?
Because the n is 1, so you can't divide by 0. There's an error. So yeah, that's what happens when the n is 1 or less. Yeah. Or not a whole number, I imagine that might be an issue as well, possibly. Yeah. Binomial distribution, let's get a reader for this one. Rob, you want to go and read?
The binomial distribution. A binomial experiment is a probability experiment that satisfies these requirements. Has a fixed number of trials. Each trial has only 2 outcomes. The outcomes of each trial must be independent of each other. The probability of success must remain the same for each trial.
Good. So again, the easiest way to figure this out is you have something that happens over and over and over and over again, and that something has only 2 possible outcomes, right? Like flipping a coin, or rolling a dice, or drawing a marble, or picking a person and asking them a question. And there can only be an is or isn't sort of situation. Like either it's a heads or it's a tails, or it's a blue marble or it's not a blue marble, or they voted or they didn't vote, right? So it's a is or isn't sort of thing. And then it has a fixed number of trials. You know ahead of time when you're going to stop. You know you're going to pick this number of people, n people, or you know that you're going to flip the coin n times, or you know you're going to draw a marble and put it back this many times, right? That's a fixed, and you know before you start when you're going to stop. And the last thing is, the most important thing is these two. The probabilities have to stay the same. So if I flip a coin, it better be the same probability each time of getting heads. If I draw a marble, remember last time if we didn't replace the marble, the probabilities changed. So that was not binomial. But if you put the marble back and replace it, then the probability stays the same, and then it would be binomial if you drew over and over again from that same group of marbles. Okay, so here's the notation. Stefan, go ahead, read.
N denotes the fixed number of trials. X denotes the specific number of successes in trials. So X can be any whole number between 0 and n inclusive. P denotes
Little p.
little p denotes the probability of success in one of the n trials. Little p denotes the probability of failure in one of the n trials. And P
Probability. I mean, anytime there's capital P in this class, it's going to be probability, in parentheses, probability of what?
X
Mm-hmm.
denotes the probability of getting exactly X successes in one of the n trials.
Great. So really, this is our probability we're looking for, right? This is the one that involves an X and N. The P's and Q's do not. The P's and Q's are little p and little q. They're kind of just a small part of the whole problem. This is the part that talks about that kind of where X and N affect it. The big P, the real probability, the probability of X. Okay, here's the rationale. This is it. The probability of X getting X successes out of N trials is NCX. In other words, you have N items, and you are choosing X of them to be a success. That tells you how many branches, how many different ways that how many different combinations you can pick to randomly assign people to be a success or a failure and still have X successes out of these N things that you're picking. In the tree example, it was how many branches would end up with that, with X successes. And then multiplying by the probability of getting a success raised to multiply by itself X times, and then multiplied by the probability of getting a failure, multiplied by the number of times, multiplied by itself the number of times that you're going to have a failure. So, you kind of look at that last part as sort of like, if I have a failure, failure, right? And then the next 3 are successes, or the next 5 are successes. Then that would be how I find the probability, right? This is, if I said, okay, I want it to be, I want the person to have ridden a bike lately. So, yes they did, yes they did, yes they did, no they didn't, no they didn't, no they didn't, no, and no. What's probably that it comes just like this? I multiply all the probabilities, right? Because it needs to be no, 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 yes, yes, oh sorry, yes, 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 no, 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 no. And all these things need to happen. And we multiply, the first person did, and the second person did, and the third person did, and the fourth person didn't, fifth person didn't, sixth person didn't, seventh person didn't, eighth person didn't. So this would be the probability of having, this many yeses and this many no's, or this many successes and this many failures out of 8, out of 8 people that you pick. And that's a probability that this happens, that it goes yes, 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 no, 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 no. But because it could be how many times do we end up with this sort of order, that's how many times we end up with exactly 3 Ps in some order or another. And there's how many ways of arranging, how many ways of having 8 people and randomly assigning 3 of them to be successes. Okay. Here it is again. Better? Or just again. And this is your quiz problem number 2. So here, the probability that x is 2 is, let's see, it's n choose x times p to the x times q to the n minus x. So, n 7, choose x is 2 times p, which is, p is what? 0.11 to the x, which is 2. And then if I have 11% success, what's my probability, if the probability of success is 11%, what's the probability of failure? 89%. Easy way to find this is to think about, if I buy something for 11 cents and I give them $1, how much change should I get back? 89 cents. That's something we're all more familiar with. It's something we've kind of worked with, the dollar and getting change from $1. It's something we have encountered much more in our lives than this. So again, go back to things that are familiar to you so that your working memory doesn't have to can have more space to think about what the new stuff, right? And not that old stuff. All right, so 0.89. And then raised to the, let's see, 7 minus 2. So my number of failures is 7 minus 2. So that's 5. That goes right there. Okay, what did you guys get for that? 142. 2. Do you guys want me to show it on the calculator, or are you guys all good? Do you guys remember how to do it on the calculator? Yes? Really? Okay. Right, so you put in, just to give you a verbal, you put in the 7. I'll show you that part. Just because some people might be confused. So I want 7 choose 2. Put the 7 in first. 7 goes first, and then do math. Go over to probability over here, so arrow over to the right to probability. And then I want NCR, arrow down to that. So I'm on this one, and then hit enter. 7 choose what? 2. Enter. And that gives me my number. And then we want to multiply that times 0.11 to the second, so it's times 0.11 raised to the second times 0.89 raised to the fifth. And you guys got 1418, which rounds to 0.142. Sorry. Okay. Does anybody need another minute to finish up 2 and 3? No? Okay, you guys are like, let's go. Okay, good. Let's go. Probability x is 6 is 10 choose 6 times 0.4 to the 6th times, well, let's see, if P is 0.04, that means that Q must be 0.6, right, because they have to add up to 1. Remember, these two add up to 1. They equal 1. And then my failures must be 10 minus 6, so that's 4. So this would be 0.6 to the 4th. There. And what did you guys get for that problem?
111.
111. Yep. Good. Thank you. Quiz problem 2. So what's N? What's X? What's P? And what's Q? Check with your neighbors. I'm going to randomly pick people to give me answers for this one.
What's over here? My brain's not working after work. I'm like, I'm sucked out.
Okay, Alyssa Q, what's my N?
Isn't it just right here?
What N is, again, N is my sample size, right? And the number of things I picked or the number of things I did. So Alyssa, what's my N?
5.
This is
5.
sample size.
Yep. 5 adults are selected. That's my N. Michael, what's my X?
3?
I'm sorry?
3?
Yes. Probability of exactly 3. That's my probability part. And then, this is kind of a harder one. Corey?
Little p is 0.85.
Right, 0.85. Remember, little p has nothing to do with X and N. Nothing at all to do with X and N. Little p is probability of success for one event. If I flip a coin, where's my coin? If I flip a coin, what's the probability that it's heads? 50%. So, but if I flip it 5 times, and I want to know the probability of getting 3 heads out of those 5, what's the probability of flipping a coin and getting heads? 1 coin and getting heads?
50.
It's still 50%. That 1 coin doesn't change. That 1 flip doesn't change. Flipping that coin will always be a 50% chance of heads. Always. So this is just saying that 1 coin flip, what's the probability of that? That never changes. It has nothing to do with X and N. Some people wanted to do 3 out of 5 or something like that. That has to do with the big probability, the P of X. That's where that comes into play. We start using that for that calculation. But not for this guy. Little p has nothing to do with N or X. It's not the little p of, it's not related to these two at all. It's the little p, not the big P. Do you guys see the difference? That's why I call him little p, because he's not really related to this problem at all. It's someone else described it as kind of for the whole population. For the whole world, what's the probability of picking somebody and having them know Twitter, of the whole world, right? 85%. So if you kind of think of it that way. So if my little p is 0.85, what's my little q? 0.15, because it's 1 minus 0.85. Good? Now you can just plug that in. So the probability of that x is 3. This is where that 3 and the 5 come into play, is 5 choose 3 times 0.85 to the 3rd times 0.15 to the 5 minus 3. You can do that if you guys want. So then maybe you work this out separately. 10, is that 10? Well, what did you guys get? Actually, let's do it that way, it's fine.
0.138.
138? Okay. Do you guys need 15 seconds with your neighbors to chat about it? No? Okay. All right, quiz problem 3. We're not trying to find the probabilities. I just want you to tell me, there are 6 people who are being randomly selected. What's the probability that more than 5 of them walk to school? So how many is more than 5 of them? Just 6. 5 is not more than 5. It's just, so only 6. Is everybody okay with that part?
It would be x equals, right? X
Well-
equals 6 or?
Yeah, x could be, yeah, I would want x is 6 would be one of them. So I want x is 6. At most 4. So here's the easiest way to think of this. Pick 4. It kind of pivots on 4. Pick a number less than 4, like 0. And pick a number bigger than 4, like 100. So if I have at most 4 television sets, if I have at most 4 television sets, can I have, or what's better for you? If I have at most $4, if I have at most $4, do I have $100? Is that possible? No. If I have at most $4, can I have $0?
Yes.
Yes, so it's the less than side. Now, to look at the number itself. If I have exactly $4, do I have at most $4?
Yes.
Yes. So it includes 4. So it includes 4 and everything below it. That's the easiest way to do it. So what are those numbers? Everyone talk to your neighbors 15 seconds or write them down if you haven't. Write those down if you haven't. 6 people, at most 4 of them have a dog. How many is that? So someone give me a number. What's one number that I could use?
0.
0. Don't forget 0. You can always have 0 successes. 0, 1, 2, 3, or 4. Good? Those are the numbers that x can be. Next, at least 4. So then what can x be there?
4, 5, and 6.
I'm sorry?
4, 5, and 6.
4, 5, and 6. At least 4 means if you have at least 4, if I have to have at least $4, you have to have at least $4 to, I don't know, to buy this thing. Then that means if you have $10, you have enough. So that's the upper side, 5 and 6. If I have $4, you have at least 4. Yes, so it includes 4 also. So 4, 5, and 6. And then less than 3.
0, 1,
0, 1, 2, 3. Or 2, 2, 1, 0.
Yep. So 3, 2, 1, and do not forget 0. Oh wait, is 3 less than 3?
No.
No. So you can't have 3. Just 2, 1, and 0. Good? Yeah.
Yes, I have a question.
Yeah.
How can you get 0 if you have 6 people?
0 successes. I picked 6 people. How many of them are math majors? 0 of them. Do you see what I'm saying? So we're random. Okay, so 6 people are randomly selected and asked if they have a VCR. Do you have a VCR?
Yes.
Okay. I get that. Might it be that you don't? Okay. Do you have a VCR?
No.
Do you have a VCR? Do you have a VCR? Do you have a, okay. Do you have a VCR? Do you have a VCR? Do you have a VCR? If I'd asked those 6 people, I would have gotten 0. Do you see what I'm saying? So it's possible to get 0 successes. If I flip a coin, I might get no heads if I flip it 6 times. It's unlikely, but it's possible. Does that make sense?
Yeah.
Yeah, so you can always get 0 successes. That's the thing we have to, people forget that. They forget about 0. Because it's possible in this case to have no successes. Here is an example. Darren, go ahead and read for us.
A survey found teenage research on limited
teenagers have part-time jobs. If 5 teenagers still do that, then find a possibility that at least 3 of them will have part-time jobs.
Right. So I'm going to define my random variable as X is the number of teenagers out of the sample of 5 that said yes, they do have a part-time job. So that's going to vary. My N is the number of teenagers that pick 5, that stays the same. What varies is how many say yes. Right? And it will change every time. Right? If I like the VCR thing. If I include you, I'm going to have at least 1 yes. If I include her, I'm going to have 1 yes. But if I don't include you guys, I won't have a yes. You know what I mean? It'll change. I could have anywhere from 0 to 6, in this case, 0 to 5 yeses. So my X is the thing that varies. I could have 0 to 5 yeses, successes, but what's my N and what's my P? N and P are always fixed. Figure out what N and P are. 15 seconds, N and P, find them. Talk to your neighbor, or else I will call on you.
Little P.
So you might ask where we are. We are in notes, chapter 5, page 3, page 3. Right? Chapter 5 notes. Yeah. Page 5? Page 5, yep. The very last page. Second to last page. Top of the second to last page. So not the last page, the second to last page, the very top. All right, so what's my N? What's N stand for again? Sample size. How many people did I choose? 5. Great. 5 are selected, so that's my N. What's my P?
3.
30%.
So again, remember, P, little p, is a probability, and it's kind of, if you kind of look at it as sort of out of everybody, out of the whole world, on average, out of the whole world, what should you get? Or you can think of it as you can do the other one, say, if I pick one kid, if I just pick one kid, what's the probability that they work part-time? If I choose one child, what's the probability they work part-time? If I pick one?
What's a 0.3?
0.3, 30%. Sorry, I wasn't trying to trick you guys, I was just asking. This is my little p, 0.30. Good? All right, so the next question is, how much is at least 3? At least 3 means how much?
3, 2, 1, 0.
Yeah. At least 3 means I have to have at least, oh wait,
Or
2,
5.
1, 0. No, 4, 5.
think about it. Okay, so at least 3 is at least 3. So then think about it like, let's go to money. You have to have at least $3 in order to be able to go to the movies. Okay, fine. I don't know where you go to the movies for $3. Whatever. You have to have at least $3 to buy this box of chocolate. If I have $10, do I have enough? If I have $0, do I have enough? No. So that means you want the upper side of it. If I have $3, do I have enough?
Yes.
Yes. So then that means 3 and up. 3, 4, and 5. So try to think of something where you have maybe encountered at least before. You need to have at least $3. You need to have at most $3. That's a little bit different, right? You can have at most 2 absences in my class before you start losing points for that. Everybody knows that, right? If every class you miss beyond 2 2 absences, then you lose a 0.5% of your grade after that. So it just chips away at your grade a little bit, which matters if you were right in the bubble at the end. Right? And then you're desperately trying, and you're thinking, if I only had missed class at one time. Oh well. All right. So we need to find the probability of at least 3. So probability of at least 3 is equal to the probability of 3,
Thank you.
or the probability of 4, right? Because at least 3 means 3 or 4 or 5. Ors I do what? Ors we
Add.
add. So we're going to add these. So find each of those probabilities and add them. Good, we can do that. Probability x is 3. Let's see, that is 5 choose. Here's a hint. The 5 choose, this part changes, but then times p is 0.30, to the x, that changes, multiplied by q. What's my q? Little p is 30%, little q is
0.7.
70, yep, to the, that. So, you guys look up for a second. This is fixed, always. My n is always fixed. My little p is always fixed. Because my little p is fixed, then my little q is fixed. So these guys are always fixed. The only thing that changes, my variable, the only thing that varies, is my x. So, if my x changes, it goes here, and then what kind of the rest of it, n minus x is my number of failures, x is my number of successes, my number of failures go here. So these two always have to add up to n, my number of successes and my number of failures. So in this case, x is 3, so 3 goes here, 3 goes there. If I have 3 successes, how many failures do I have? 2. Because 3 plus 2 gives me 5. And I can find that. So I go to my handy dandy calculator, and I'm going to do 5, so I'll move there first. 5 math, probability, NCR, 3, enter, times 0.3 to the third, times 0.7 to the second. So this, just to give you a hint, this is one of the rare times when you can just do them all straight out, because order of operations falls in our favor. It goes like it should go. That's not always going to be the case, but this time it is. And I get 0.1323. You guys find the probability of that x is 4, and find the probability that x is 5. So do that now kind of quickly, if you can. And then we'll take a break until, and then add them up, right? And then we'll take a break till 5 after.